The Doppler Effect by Taswi, Manassa, and Forum. What is the Doppler effect? The Doppler effect is the increase in the frequency of the waves as the object and the observer move towards each other. It is also the decrease in the frequency of the waves as the object and the observer move away from each other. Two major examples of the Doppler effect are the redshift and the ambulance passing by. As the ambulance moves towards you, the pitch becomes higher, and while it moves away, it becomes lower. This is due to the Doppler effect. The experiment was a model that depicts how the Doppler effect works. Research question: how will the paper rings be positioned when the car is stationary and when it is moving? Hypothesis: if the car is stationary, then the paper rings will spread out evenly around the car. If the car is moving, then the paper rings will be clustered in the direction of motion and spread out in the opposite direction. Materials: paper, scissors, a toy car, tape, and a ruler. Procedure: the procedure is pretty simple. Cut a piece of paper into several thin strips. Join the ends together with tape. Make each ring larger than the other, and then place the car at the center. When the car is in the center, the object is stationary. Then, move the car to the right. After that, move the car to the left. See what happens. Record your observations. Observations: when the car was stationary, the paper rings were evenly spread out. Each ring gradually had a larger radius. When the car was to the right side of the rings were gathered up while the left side were evenly spread out. On the left side, the same thing happened, but vice versa. Analysis: the model demonstrates how the Doppler effect works in correspondence to a stationary and a moving object. The object is the car and the paper rings represent the sound waves. The rings are evenly spread out when the object is stationary. The closer the object, the smaller and high-pitched the sound waves are. The model depicts this since the radii of the inner circles become smaller. When the object is moving to the right side of the rings are bunched up while the left side is spread out further. In the direction the object is moving, the wavelengths are shorter and the pitch is higher, while in the opposite direction the wavelengths are longer and the pitch is lower. Although the sound is the same throughout the process, it is perceived differently. A person standing close will hear a louder sound than a person standing far away.
Marine biologists study plants and animals in marine environments by conducting programs of exploration and research. To become a marine biologist, you must have a keen understanding of biology, chemistry, geology, and physics, and have a degree in oceanography. Skills a marine biologist needs: must have good communication skills to convey their findings to reports and essays, have critical thinking and problem-solving skills to carefully analyze data, and must have interpersonal skills to work well with other scientists. Job possibilities: marine biologists are employed by governments, educational institutions, and private companies engaged in exploration of seafloor deposits and sea farming areas, or they may be self-employed. Responsibilities: marine biologists have the responsibility to investigate marine ecosystems, collect data, analyze data, and display findings to the rest of the scientific community. Marine biology in Ontario. In 2022, there should be almost 33,000 jobs available associated with marine biology. Marine biology has an estimated salary of $46,000 to $109,000. Sonar. Sonar, short for sound navigation and ranging, is helpful for exploring and locating marine organisms because sound waves travel further in the water than the radar or light waves. Sonar is a system in which a sound wave is emitted and then reflects off other objects and bounces back. This is due to the Doppler effect. This is important for marine biologists because if they emit a wave of known frequency and it bounces back with a different frequency, they can calculate the speed and orientation of that object.
Created using Powtoon.